Hi friends, this video is on motion of physics part 12 out of 14 numericals. This video is brought to you by COACHINGCARES.IN, designing future by smart education. Under this lesson, we are going to study equations of motion. As you can see, equations of motion, basically there are three equations of motions and we can call kinematic equations. These three equations we call kinematic equations. So we will study we'll establish all the relations. The values and the quantities are utilized in these equations to understand or to describe the motion of any object. One is the displacement, another one is the time taken, initial velocity, final velocity. These are the quantities, actually these are the quantities which are used or utilized to define or describe the motion completely in different conditions, and these equations are established with these all these quantities. So first equation is v is equal to u plus at. Second equation is s is equal to ut plus half at square, and the third one is v square is equal to u square plus 2as. So these are the very important equations in motion chapter, and we'll study further in the further slide the derivation of all these. Okay, let us understand the derivation for the equation number 1, v is equal to u plus at. So to understand this derivation, we'll start acceleration. Suppose we are assuming u is the initial velocity, v, we are assuming this is final velocity, a is the acceleration, and t is the time. So let us define all these parameters. Now acceleration, as we know, a is nothing but rate of change of velocity. We all know this fact. So rate of change of velocity is equal to change in velocity, final velocity minus initial velocity, and rate of change means time taken, that is t. So a is equal to v minus u by t, or we can write it v minus u is equal to at, or we can write v is equal to u plus at. So this is the final equation, and this is the derivation from where we derived it. We derived it from the acceleration formula, and this is the equation number 1. This is equation number 1. Now let us understand further slide equation number 2 derivation, which is s is equal to ut plus half at square. So this we'll understand by this graph. Let us say this is x, sorry, this is y-axis, this is x-axis, and this is y-axis. This is time along x-axis we taken, and this is velocity along y-axis we have taken. So now let us study this graph. One straight line graph is there. Suppose this is the straight line graph between velocity and the time, assuming starting from point A and reaching to point B, that is straight line. And this is y-axis, as we know. So you just try to understand this. Object start the motion from point A and it ends the motion at point B, and this is the graph. This is a plotted graph of the whole motion describing the motion. So you just understand along the velocity axis, this is the initial velocity where object starts, we denote it by u, and this is the final velocity, we denote it by v. So u is basically this distance, and this v is basically the whole distance from the x-axis. At the same time, if suppose we want the distance covered or displacement is equal to, as we studied in the previous slides, area under VT curve, that you know already. So area under VT curve we can understand this way. Suppose this is point C and this is point D. So okay, I just connect it here. This is point E. So this whole area is the area under VT curve, and this is called the displacement. So this displacement will be equal to, according to this statement, area of A, B, C and D, which is nothing but area of triangle ABE plus area of rectangle rectangle A, E, C and D. I mean this area. This is one triangle. This is two is the rectangle. So we'll further, extend it. Area of this triangle is nothing but half BE into AE plus area of this rectangle is nothing but EC multiplied by DC. So we'll see, I mean, up to this point, we assume this is the time taken. We are assuming t, and here DC is nothing but equal to AE. This DC we can write is equal to AE. Further, we solve it. Half BE. B is nothing but this is V from this origin and this is U. So BE will be V minus U. And EC is nothing but U. And AE or DC is nothing but T. So we can write displacement is nothing, we are assuming S, so S is this one, or S is equal to half A T plus U T. This V minus U, you can understand like this, V equal to U plus AT. So we can write it V minus U is equal to AT. So we can put this value of V minus U is equal to AT. So S is equal to UT. I mean, we written this BE is V minus U. BE V minus U and AE is nothing but T. We forgot to write it. Let us write it T. So that will become V minus U will become A according to this. I mean from the equation number 1. From equation number 1. And T multiplied by T, so it will be half AT square. So we can write this S is equal to UT plus half AT square. This is the second equation that we derived. So that is called equation of motion, and number is 2, equation number 2. So this derivation comes from this displacement under the VT curve that we written it initially. S is equal to area of this ABCD, this whole shaded area. Then we derived it. We again expanded it. Area of this whole, I mean this quadrangle, quadrilateral, we can divide it in two parts. One is this triangle BEA, another one is the rectangle AECD. So we return it, then we put it the values of the sides, I mean BE and all these sides, we put it this value, and we replaced V minus U from the equation number 1 by AT. So this is half AT square. It comes out like half AT square, this term, plus UT. So S is equal to UT plus half AT square. This is the equation number 2 derivation complete. I hope you got it completely. Now we'll see another slide, equation number 3, the derivation of this equation number 3. So this derivation we'll understand this way. We know S is equal to the equation number 2. S is equal to UT plus half AT square. We know this. So we'll put the value, putting the value of t from equation of motion number 1, equation of motion number 1, which is nothing but v is equal to u plus at. So t will be v minus u divided by a. We can write it. So we'll write the value of t in this equation, which is equation number 2. Is putting the value of t in both the terms, we'll get s is equal to u v minus u oblique a plus half a t square, means v minus u oblique a square. Further we resolve, so we'll solve it. That will become that is uv by a minus u square by a plus we'll write half half v square minus half u square plus half u square minus 2 multiply by or let us write it in this way. This whole thing we'll write another way, that is half a v square minus u square plus 2 u square minus 2 uv and we can write it a square. We can write it in this way. So further we can write both the terms uv by a minus u square by a plus a, it will cancel this square, so that will become half we'll write this term here v square plus u square by 2a minus uv by a. So we'll get this equation after this solution. So this uv by a, it will get cancelled this term, and further we can resolve this. So that will be by we take a outside or we can write it in this way u v square, we can write, we take this common outside, v square plus u square minus u square by a. Okay, So or we can take the common outside, 1 by 2a, 1 by a we are taken outside, and further we can write it v square by 2 plus u square by 2 minus u square. We can take this a at this side, or we can take 1 by 2 outside. We can write this way: SA is equal to v square by 2 plus u square by 2 minus u square. So we can take 1 by 2 common outside. So that will become v square plus u square minus 2u square. So this will become 2as, we taken this at this side, is equal to v square plus u square minus 2u square. Or we can write v square is equal to minus 2u square. So this will be, this is plus u square, so it will be minus u square. So this u square will go this side. So this will be plus. So v square is equal to u square plus 2as. So finally we'll get this equation, which is nothing but the third equation of motion. So this is third equation of motion number 3. So this is the whole derivation of this one. So you can have a look of that. We started actually from equation number 2, which is s is equal to ut plus half at square, and we just put the value of t from the equation number 1, which is v is equal to u plus at, and t is equal to v minus u by at. We just substituted this value of t in the equation number 2, equation of motion number 2. And after resolving this whole, we can get finally v square is equal to u square plus 2as. This is the derivation of the motion, equation of motion number 3. Now let us solve this problem by using equations of motion. So here let us see this problem. A car starting from the rest moves with the uniform acceleration of 0.1 meter per second for 2 minutes. Find the speed acquired and the distance traveled. So here you just note it down. From the rest, car is starting from the rest. So u, we are assuming the initial velocity u, because it is at rest, so it is 0. And it got the uniform acceleration a, that is 0.1 meter per second for 2 minutes. So time is also given here 2 minutes, which is nothing but 2 into 60, 120 second. So it is asking speed. Speed is what? We have to calculate the speed and distance. which is S, and speed acquired speed is the final speed V. So we have to calculate both. So let us solve this by using equation number 1. V is equal to U plus A T. We'll put all these values. U is 0, AT is 0.1 multiplied by 120. So that will become 112.0 meter per second. So this is the acceleration. This is minus 2 actually per second square. So we got finally the speed. I mean speed V is equal to 12 meter per second. This is the solution 1. Now for second solution we need S. We know the equation of motion S is equal to ut plus half at square. We'll put all the values. U is 0 plus half A is given 0.1 and t square it is given 120 square. So this is all 0. So we can write it in this way, 0.1 into we can write this way, oblique 2. So that will become, this is the distance S, and this is the solution, the final answer. I'm sorry, it is multiplication by 0.1, so we'll write it here, 720. 720 is the final answer. So S will be is equal to 720 meter. So finally we got this by using equation number 2, equation of motion number 2, and we calculated V, which is the speed acquired after the acceleration for 2 minutes. This is 12 meter per second. So like this we can solve the problem. We can understand, actually we have to analyze and understand the conditions. We have to understand the values, whether object is at rest or object is in motion. If it is at rest, we will consider the initial velocity 0. Then we can find the final velocity or final speed of the object, and like that we can resolve many numerical problems by using all the 3 equations of motion in this chapter. So I hope you all you are able now to understand the derivation and all the 3 equation of motions, and you can utilize all these equations of motion to solve the numericals in this chapter. So thank you. Thank you for visiting COACHINGCARES.IN. Watch free educational videos, get best quality study material, study from the best tutors and mentors. Thank you once again.